everyone. I am Dr. Saurabh Saxena. I'm working as Assistant Professor in Department of Applied Science and Humanities, ABES Engineering College, Ghaziabad. The topic for today's discussion is Dirichlet's integral. So here we go with the statement. Dirichlet integral may be considered as the three-dimensional integral for which two particular things should be the same. That is, the function that is to be integrated this is x to the power L minus 1, y to the power m minus 1, z to the power n minus 1. The function must be in the same structure or same form. And the region for which it is to be integrated must be defined for x positive, y positive, z positive, and x plus y plus z is less than equals to 1. So if such type of function is to be integrated over the region which is defined by these boundaries, then the value of such integral may be given as gamma L, gamma M, gamma N divided by gamma L plus M plus N plus 1, where L, M, N, they may be referred from the powers of the variables x, y, and z on the left hand side. The given region of integration may also be considered, or it may represent as the volume in the positive octant of the Cartesian coordinate system bounded by the coordinate planes x equals to 0, y equals to 0, z equals to 0, and beneath the plane x plus y plus z equals to 1. So this may be considered as the geometrical interpretation of the region for Dirichlet's integral. If further you want to apply the Dirichlet's integral, these two things must be in the same form. That is, the function should be in the form of x to the power something minus 1, y to the power something minus 1, z to the power something minus 1, and the region must be defined as x positive, y positive, z positive, positive or less than equals to 0 as well, and x plus y plus z is less than equals to 1. Likewise, the three-dimensional integral, we can also define Dirichlet's theorem for two-dimensional integral. Here it is. So, Dirichlet's integral for two dimension may be given as double integral over the region R, x to the power L minus 1, y to the power m minus 1, dx dy is equals to gamma L, gamma m divided by gamma L plus m plus 1. Here we notice that in case of three dimension and in case of two dimension, only one difference is there, that the third variable z and the third dimension of the integral is omitted. Here the region R is defined for x greater than equals to 0, y greater than equals to 0, and x plus y is less than equals to 1. It may also be considered as the region bounded by the y-axis, that is x equals to 0, the x-axis, that is y equals to 0, and the line x plus y equals to 1. So below this line, on the right of y-axis and above the x-axis, this is the region R. So if such kind of two-dimensional integral will occur, we will be using direct concept of Dirichlet's formula, that is gamma L, gamma m divided by gamma L plus m plus 1. Now we'll go through that how these tricks oblique formulas are used in the problems. So here we go with the problem. This is the question. Evaluate triple integral x y z dx dy dz, where v is defined by x greater than equals to 0, y greater than equals to 0, z greater than equals to 0, and x plus y plus z is less than equals to 1. Here we observe that the function is in the form same defined as for Dirichlet's integral. So let us consider the I is equals to triple integral x to the power 2 minus 1, y to the power 2 minus 1, z to the power 2 minus 1 dx dy dz over v, where our v is given as x greater than equals to 0, y greater than equals to 0, z greater than equals to 0, and x plus y plus z is less than equals to 1. Now the two things that I have mentioned, let us observe. the function is in the same form, x to the power something minus 1, y to the power something minus 1, z to the power something minus 1. And the region is also in the same form, x greater than equals to 0, y greater than equals to 0, z greater than equals to 0, and x plus y plus z is less than equals to 1. Then can we use Dirichlet's integral? So yes, we can make use of Dirichlet's integral. So what is the formula for Dirichlet's integral? X to the power, this particular term may be considered as L, this may be considered as M, this may be considered as N. So by Dirichlet's integral, this value of the integral may be given as gamma L, gamma M, gamma N divided by gamma L plus M plus N plus 1. That is gamma 2, gamma 2, gamma 2 divided by gamma 2 plus 2 plus 2 plus 1. Now value of gamma 2 is 1. So it is 1 into 1 into 1 upon gamma 7. And gamma 7 is factorial 6. And value of factorial 6 is 720. So this is our answer, 1 by 720. Let's take the second example. Here it is the question. We have to evaluate this integral, triple integral dx dy dz over v, where v is defined for x greater than equals to 0, y greater than equals to 0, z greater than equals to 0, x square plus y square plus z square is less than equals to 1. Here in the condition, that is the region, three conditions are same, but the fourth one is not matching. So what in this case, if we want to make use of Dirichlet's integral, what we'll do, we'll let x square is equals to u. If x square is equals to u, we can think like x is equals to root u, and dx is equals to 1 by 2 u to the power minus 1 by 2 du. In the same way, let y square is equals to v. So y is equals to root v, and dy is equals to 1 by 2 v to the power minus 1 by 2 dv. And third variable, that is let z square is equals to w. It gives z is equals to root w, and dz is equals to 1 by 2 w to the power minus 1 by 2 dw. By making use of the given integral terms as triple integral, dx may be written as this, 1 by 2 u raised to the power minus 1 by 2 du, then 1 by 2 v raised to the power minus 1 by 2 dv, 1 by 2 w raised to the power minus 1 by 2 dw. Here the region of integration was given in terms of x, y, z, and it was named as v. We will consider our new region as v dash, and we will define here v dash is v dash is for, now v dash region represents the region in UVW system. So if x is greater than equals to 0 and we are dealing u as x square, so u will definitely be greater than equals to 0. Similarly, v will definitely be greater than equals to 0 and w be greater than equals to 0. And x square, that is the fourth condition, x square may be written as u plus y square, that is v, plus z square, that is w, is less than equals to 1. So now in terms of UVW, we have got the integral. It may further simplified and restructured as I is equals to 1 by 8 triple integral over v dash u raised to the power 1 by 2 minus 1, v raised to the power 1 by 2 minus 1, w raised to the power 1 by 2 minus 1, du, dv, dw. And v dash is for u positive, v positive, w positive, and u plus v plus w is less than equals to 1. Now, see 1 by 2, 1 by 2, 1 by 2. It becomes 1 by 8 here. U to the power minus 1 by 2. If I want to make use of Dirichlet's integral, the function must be written in the form variable to the power something minus 1. So u to the power minus 1 by 2 power. It may be written as 1 by 2 minus 1. Similarly, in case of v, similarly in case of w. Now this particular integral is Dirichlet's integrals form, and the value of the same may be written as 1 by 8 gamma 1 by 2 gamma L gamma M gamma N divided by gamma L plus M plus N plus 1. We all know gamma 1 by 2 is under root pi. So 1 by 8 root pi divided by 1 by 2 plus 1 by 2 plus 1 by 2 plus 1. So this becomes gamma 5 by 2. It is equals to 1 by 8 pi root pi, and gamma 5 by 2 may be written as 3 by 2 into 1 by 2 into root pi. This is root pi and root pi cancel out. This is 2, 2 ja 4, 2 ja 8. You will be getting 5 by 3 into 2, 6 as your answer. So in the first question, we didn't require any replacement or any substitution, as the region was perfectly in the form of Dirichlet's integral. But in the second question, the region was not in the form of x plus y plus z. So we have to assume x square as u, y square as v, and z square as w. And then the integral in terms of uvw becomes the Dirichlet's integral, and the value of which was obtained as the formula of Dirichlet's integral. So this is the reference section. Disclaimer. Thank you very much.